In this clip, you will learn how to integrate with Azure Table Storage using the Azure Tables client library for .NET. We are in Visual Studio and I've opened NuGet Explorer, pointing to the NuGet package we need, azure.data.tables. Let's install it. There we go. From this package, we can now use a table service client object, which you can look at as a proxy around Azure Table Storage. I'm going to want to inject one of these whenever we want to search for destinations. But to be able to do that, I must of course first register it on the container. Let's open Service Collection Extensions. There's a method here, register persistence services, which is meant specifically for something like that. It's meant to register persistent services related to the API, and table storage is one of those. So the table storage client can be registered here. So let me call into services.addScoped. Now I can't just pass through table service client here as type, as I need to initialize such a client with a means of authentication. So let me pass through a small factory action in which we can new up the client. So that's addScoped, and then return new table service client. Alright, so that's the factory. Of course, this won't work yet, because we must still provide means of authentication. Different methods exist for that. We just saw that, like a shared access signature and an access key, but also a related connection string, as we'll immediately see. Constructor overloads for the table service client here exists. We can pass through a connection string, as you can see, but we can also pass through a shared access signature credential and so on. We could actually do that. We created that shared access signature credential in the previous demo. So we could just new one up here, new Azure SAS credential, and then pass through the signature here. That'll work, but I want to show you different ways of achieving things. So let's use a connection string this time. TravelInspiration.api is, after all, an app under our control. So we trust it, and we can be sure that it can safely store its credentials because it is executed on the server, not on the client. But where do we find that connection string then? Let's open the portal. Let's go to the access keys blade of the storage account. And as you can see here, we could ask for the key, but we can also ask for the connection string. So let's show this, and let me copy that one. Then let's open the app settings file, and let me add the connection string here. Let's name it Travel Inspiration Storage Connection String, and let's input what I just copied to my clipboard. Alright, back to the service collection extensions. I can now refer to that from here. Let me make sure I copy over the correct key. This is not something you want to make a typo with. There we go. And like that, our table service client is newed up in the factory. And we can now inject it wherever we need it. And we need it when searching for the destinations. So let's open the search destinations feature or slice, and let's inject it in the handler, because that's where we need it. Now let me store that in a field. Change that a bit. There we go. We now have a field, Travel Inspiration Table Service Client. We can use that in our code. So I no longer need these hard-coded values here. I now want these to come from table storage. But how do I do that then? Well, we've got our Travel Inspiration Table Service Client. On this you can find the methods you would expect. You can create tables, delete one, query the list of tables that exist, and so on. But we don't want to create, delete, or query a list of tables. We want to work with the entities that exist inside of one specific table, our destination table. For that, we need a reference to that table, and that is exposed via a table client. So what I need to do here is store a table client in a variable so I can use it later on. Let's say destinations table client. And I'm going to get that by calling into .getTableClient, passing through the name. And there we go. On this destinations table client, we now find methods to work with the entities in that table. I can add entities, I can delete entities, update entities, both asynchronously and synchronously. So what we need is the query async method. We want to query a table, so what we need is the query method. This returns a pageable table, and that's good because we implemented a rudimentary form of paging down here in which we only took the amount of items to return. So that could be the size of one page. We can also pass through a filter, and that's a good thing because we have a potential search for query string value we want to filter on. And if we look at what else is possible, we see we can also pass through an IEnumerable of string named select, which allows us to select only the fields we need. So all of this is looking quite good. But what's returned by query is something of type Azure Pageable of type T. And if you look at what type T is, then there's a few constraints on it. It should be a class and it should implement iTable entity. How do we work with that? Well, there's multiple ways to approach that. We can create a class that implements iTable entity, which can be convenient to work with, but it also requires a bit of additional effort and a small increase in complexity that may not be necessary. Another way is to use the built-in table entity class, which is a generic way of working with table entities. It's actually a dictionary with the field name as key and the value as value. This offers the advantage of being able to easily work with entities with different fields in the same table. But anyway, this is a design detail that goes beyond this course. Just know that both are possible. I'm going to use the built-in table entity class. So, the first thing we wanted to pass through was that filter, right? We also wanted to pass through a page size and a select clause. Let's create that filter first. So, to create a filter, we can use tableclient.createQueryFilter. But when do we want to create a filter? Well, only when the search for value has been passed in. So, if search for is null, then we don't need a filter. Otherwise, we use tableclient.createQueryFilter to pass through a filter. And the filter we want is checking whether the name contains the search for string. If you're wondering where all of this is coming from, this too is the OData standard at work. So the way to implement this depends on what exactly you need, but you can find all those functions you can use inside of an OData query on the odata.org site. In essence, what we're doing is creating the request that we would otherwise send via the REST API. So all this create query filter thing actually does is ensure that what we input here is escaped correctly before it is sent to the REST API. Okay, so then we can use this filter. Let's say we store the destinations in the destinations variable. And to query them, we use destinations tableclient.query. The first thing we pass through is the filter we just created. The second thing we could pass through is the amount of items we want on a page. We know what that is. That is our amount to return here. There we go. The third thing we want to pass through were the fields to select. We needed to pass that through as an IEnumerable of string. Oh, so I want the identifier. And I want the name. And of course, as a best practice, it's also a good idea to pass through the constellation token. The last thing we need is passing through the type we want to end up with, which is table entity, as mentioned before. So destinations will be an Azure.pageable of type table entity. At this moment, nothing has been sent to table storage yet. That only happens when a page is requested. So how do we do that then? We call as pages on our variable, and then we get the first page. Of that first page, we get the values. Those are the rows coming from our table storage. So for each of those, we create a new destination DTO object to return. The ID is the identifier. Let's not forget select if I want to select each of them. ID is the identifier, so I call getInt32 on the identifier field. If for some reason that's null, it shouldn't be of course, I set it to -1 and the name property is set to the value of the name field. And then I call toList on that. This doesn't seem to resolve. Let's have a look why. It appears that the required member image name is not set. Well, that kind of makes sense. We don't have that. As explained previously, I was going to use blob storage for that. So let's remove that. We no longer need it here. There we go. All right. Finally, we return the results. Let's give that a try. And I think this is not going to work. And I'll immediately explain why. Let's search for destination San Francisco. And we get an internal server error. An unknown function with name contains was found. What's that about? I'm pretty sure that that function exists in OData. Well, let's have a look at Microsoft's documentation for the query operators that are supported by the table service. In the unsupported query operators list, we indeed find contains. These link statements you see here eventually translate into OData functions, so from this we can gather that the contains OData function, used directly as we did, also isn't supported. Typically those functions that require inspecting all rows are not supported. And if we think about it, that actually makes sense. Table storage is and remains a potentially huge NoSQL data store. It isn't optimized or intended for scenarios like this. If you need something like this, you're better off using a relational database like Azure SQL, as we will do in the next section. Take, which we use for paging, is supported, and so is select. So what do we do then? Well, we could just get rid of our filter altogether, but there is something that we still can do. Checking if something is equal to something else is supported. So that's essentially a simple where clause. And we can do that. So instead of using contains here, I'm going to state that it should only return exact matches, where name equals the search for string. This is not exactly the same type of functionality as before, but it is something that comes close and that is supported. If you really need the same type of functionality, table storage is not a good option. So for the demo, we're simply going to assume that we want the name to equal the search for string. Let's give this another try. Let me add another request here. This one searches for Antwerp, Belgium. And there we go. This now works as expected. So this is how you can integrate with table storage from your .NET code. But not everything is possible, as you've just noticed. I previously added a few search destinations to table storage, but doing that via the portal isn't always the most convenient way. Storage Explorer is another option for that. Let's have a look.